Picture this. You wake up tomorrow morning and archaeologists announce they've discovered the ruins of a massive city buried beneath the Amazon rainforest. But here's the twist. The carbon dating shows it's not thousands of years old. It's 400,000 years old. Your morning coffee suddenly tastes different, doesn't it? Because everything you thought you knew about human history just got flipped upside down. What if I told you that the entire story of civilization we've been taught is potentially missing some pretty massive chapters? What if advanced societies were building, creating, and innovating when our textbooks say humans were barely figuring out how to make stone tools? What if we're not the first intelligent civilization to call Earth home, but just the latest in a long line of forgotten peoples? Today, we're diving headfirst into one of the most mind-bending questions in human history. Could an advanced civilization have existed 400,000 years ago? And before you roll your eyes and click away thinking this is some conspiracy theory nonsense, stick with me, because the evidence, or rather the lack of evidence, might surprise you more than you think. I'm about to show you why mainstream science approaches this question with extreme caution, why the odds are stacked against us ever finding proof even if it existed, and why asking this question teaches us something profound about the fragility of everything we've built. By the end of this series, you'll never look at a timeline of human history the same way again. But first, let me paint you a picture of just how vast 400,000 years really is. Because our brains aren't designed to process time spans this enormous, and until you grasp the sheer scale we're talking about, the rest of this won't make sense. Think about your entire life. Let's say you live to 80 years old. That's a pretty good run, right? You'll see incredible changes during those 8 decades. Technology will advance, societies will shift. Maybe you'll witness humanity's first steps on Mars. Now take that lifetime and stack it up against 400,000 years. You'd need to live your entire life 5,000 times over to equal that span. 5,000 complete lifetimes, back to back. To put this another way, our oldest recorded civilizations are about 5,000 years old. Mesopotamia, ancient Egypt, the Indus Valley. Everything we know about cities, writing, mathematics, and organized society comes from this relatively recent period. But compared to 400,000 years, that's like a single page in a massive library. We're trying to understand an entire book by reading one page, and we're convinced we've got the whole story. Here's where it gets really interesting. 400,000 years ago, human-like beings were already walking around on this planet. They weren't identical to us, but they were remarkably close. Their brains were approaching the size of modern humans. They were crafting sophisticated stone tools, controlling fire, and surviving in diverse environments across multiple continents. These weren't primitive creatures stumbling around in the dark. These were intelligent beings capable of learning, adapting, and innovating. So here's the uncomfortable question that keeps me up at night. If beings with near-human intelligence existed for such an enormous span of time, why do we assume they never pushed beyond basic survival? Why are we so confident that no group ever developed something we might recognize as civilization? The standard answer is simple. We have no evidence, no ruins, no artifacts, no traces of advanced technology. But here's the thing that most people don't realize. The absence of evidence isn't necessarily evidence of absence, especially when we're talking about time scales this massive. Let me explain why finding evidence from 400,000 years ago is like searching for a specific grain of sand on every beach in the world. First, consider what happens to stuff over time. Wood rots, metal corrodes, fabric disintegrates, even stone structures crumble and get ground into dust. Most materials that make up daily life are incredibly fragile when measured against hundreds of thousands of years. Think about our own civilization for a moment. If every human disappeared tomorrow and you came back in 10,000 years, what would you find? Most of our cities would be overgrown ruins. Our plastic might survive in some form, but our electronics, our buildings, our infrastructure would largely be gone. Now multiply that decay by 40. That's the challenge we're facing when looking for traces of ancient civilizations. But the Earth itself is working against us in even more dramatic ways. This planet is not a museum carefully preserving artifacts for future archaeologists. It's more like a giant recycling machine that's constantly destroying and rebuilding everything on its surface. Mountains erode into plains, rivers carve new valleys and flood old settlements. Glaciers advance and retreat, grinding everything flat in their path. Volcanic eruptions bury entire regions under layers of ash and lava. Earthquakes reshape coastlines and swallow landscapes whole. Continental drift slowly moves entire land masses across the globe. Over 400,000 years, these geological forces are absolutely relentless. Even if an ancient civilization had built monuments as impressive as the pyramids, the odds of them surviving all of these natural recycling processes are incredibly small. The Earth doesn't care about preserving history. It just keeps churning, destroying, and rebuilding. Then there's the ocean problem. Most humans throughout history have lived near coastlines. It makes sense. Water is essential for life, and coasts provide access to marine resources and transportation routes. But coastlines are some of the most unstable places on Earth. Sea levels rise and fall dramatically over geological time. At the end of the last ice age, rising seas swallowed vast stretches of land where people once lived. If you multiply these sea level changes over 400,000 years, almost every ancient shoreline has been erased multiple times over. If an advanced society had built their cities near the water, as most societies do, much of their civilization could now be sitting on the ocean floor, buried under layers of sediment, where we'd never think to look. Here's another mind-bending reality check. Archaeologists have studied only a tiny fraction of Earth's surface. Most of the planet is covered by oceans, deserts, jungles, and mountain ranges that are difficult or impossible to excavate. Even on accessible land, we've barely scratched the surface. We're working with an incredibly small sample size and trying to reconstruct the entire story of human development from these scattered fragments. It's like trying to understand the plot of a 1,000-page novel by reading 10 randomly selected sentences. You might get some clues about characters and themes, but you're definitely missing most of the story. And if some of those crucial pages were written 400,000 years ago. They've probably been torn out, burned, and scattered to the wind by now. But let's dig deeper into what 400,000 years actually means in terms of human development. This isn't some arbitrary number I pulled out of thin air. This time frame sits right in the sweet spot of human evolution, where things get really interesting. Modern humans, Homo sapiens, have been around for roughly 300,000 years, according to our current fossil evidence. But human-like species with large brains and sophisticated behaviors go back much further. Homo erectus existed for nearly 2 million years and spread across Africa and into Asia. They mastered fire, crafted complex tools, and adapted to diverse environments. 2 million years is an absolutely staggering amount of time for a species to exist and evolve. Neanderthals, who we now know were far more sophisticated than early researchers believed, had brains as large as ours, or even larger. They buried their dead, created symbolic art, and developed tools specifically adapted to their environments. The mysterious Denisovans, known mainly from DNA analysis, were closely related enough to modern humans that we interbred with them. All of these species were experimenting with intelligence, creativity, and social organization for vast periods of time. So when we talk about 400,000 years ago, we're not talking about some prehistoric void where nothing interesting could have happened. We're talking about a time when multiple human-like species coexisted, each developing their own approaches to survival and potentially much more. The key insight here is that intelligence didn't suddenly appear out of nowhere 10,000 years ago with the development of agriculture. It was building gradually across countless generations, with different species and groups pushing the boundaries of what was possible with the mental tools they had available. Now, I know what you're thinking. If these ancient beings were so intelligent, why don't we see evidence of cities, writing systems, or technology? Here's where we need to challenge our assumptions about what advancement actually looks like. When most people hear advanced civilization, they picture something that looks like our modern world. Skyscrapers, computers, automobiles, electronic devices. But advancement doesn't have to mean digital or industrial. It simply means reaching a level of knowledge, organization, or capability that goes beyond basic survival needs. Consider the ancient Egyptians. They built monuments so precisely engineered that modern experts still debate exactly how they achieved it. The Maya created calendars that tracked celestial movements with incredible accuracy. Neither civilization had computers or electricity, yet their achievements required deep understanding of mathematics, astronomy, and engineering principles. An advanced society 400,000 years ago might not have looked anything like our technological civilization. They might have mastered nature in completely different ways. Perhaps they developed sophisticated techniques for managing ecosystems, predicting weather patterns, or navigating by stellar observations. Maybe they created sustainable technologies using organic materials that left no permanent traces. They might have focused their intellectual development on biological knowledge rather than mechanical engineering. Imagine a society that became incredibly skilled at breeding plants and animals for specific purposes, creating living tools and resources rather than manufactured ones. Or perhaps they developed forms of social organization, communication systems, or memory techniques that gave them tremendous advantages without requiring permanent structures. These alternative paths of development would be nearly invisible to archaeologists today. Knowledge-based technologies, organic materials, and social innovations leave few traces in the archaeological record. But they could still represent genuine advancement, just along different lines than the path our civilization happened to take. The more I think about this possibility, the more I realize we might be looking for evidence of ancient advancement in all the wrong places and in all the wrong ways. We're essentially playing a cosmic game of hide and seek, but the evidence had 400,000 years to hide, and we've only been seriously looking for a few decades. Let's talk about something that'll make your head spin. The problem of missing evidence goes way deeper than just things decaying over time. We're dealing with what I call the fragility paradox. The more advanced a hypothetical ancient civilization might have been, the less likely we'd be to find traces of it today. Think about it this way. If an ancient society had developed sustainable technologies that worked in harmony with natural systems, they would have left behind virtually nothing for us to discover. A civilization that built with living materials, that created tools from organic compounds, that developed energy systems based on biological processes. All of that would have been reclaimed by nature within a few thousand years, let alone 400,000. Meanwhile, our modern civilization is leaving behind a massive signature that will persist for millennia. Plastic pollution, nuclear waste, concrete structures, metal alloys that don't exist in nature. Future archaeologists will have no trouble figuring out that we were here. But what if being truly advanced means leaving no trace? What if the absence of evidence is actually evidence of a more sophisticated approach to living on this planet? This flips our entire understanding of what to look for on its head. We're searching for the archaeological equivalent of footprints. But what if advanced beings learn to walk without leaving any? Here's another angle that keeps me awake at night. Let's talk about the knowledge problem. Even if ancient civilizations never built lasting monuments, they could have developed incredible knowledge systems that were passed down through oral traditions, memory techniques, or methods we haven't even imagined. Look at what happened to human knowledge just within recorded history. The Library of Alexandria burned down, and countless works of science, philosophy, and literature vanished forever. Roman concrete recipes were lost for over 1,000 years. Indigenous peoples around the world possessed sophisticated knowledge about navigation, medicine, and ecosystem management that was dismissed or forgotten when other cultures encountered them. If knowledge can disappear so easily within a few thousand years, imagine what could be lost across 400,000 years. Entire systems of understanding about mathematics, astronomy, engineering, or natural sciences could have been developed, refined, and then completely erased multiple times over. But here's where it gets really wild. What if knowledge wasn't just lost randomly? What if there were deliberate resets? I want you to imagine a scenario that sounds like science fiction, but might be more plausible than you think. Picture a civilization that reached a high level of development, then faced some catastrophic event. Maybe climate change, maybe a natural disaster, maybe internal conflict. The survivors scatter, their numbers reduced dramatically, their complex society collapsed. These survivors carry fragments of the old knowledge, but without the infrastructure and specialization that supported it, most of that knowledge becomes useless. A person who understood advanced metallurgy can't practice their craft without mines, furnaces, and trade networks. Someone who specialized in complex mathematics has no practical application for their skills when the priority becomes basic survival. Over a few generations, the sophisticated knowledge gets simplified into basic survival skills, then further distilled into stories and myths, then eventually forgotten entirely. The cycle starts over from scratch. This isn't just speculation. We can see smaller versions of this pattern throughout recorded history. After the fall of the Roman Empire, much technological and organizational knowledge was lost in Europe. It took centuries to redevelop capabilities that had once been routine. Now imagine this cycle repeating not once, but dozens of times across 400,000 years. Each rise and fall separated by tens of thousands of years, each reset wiping the slate almost completely clean. From our perspective today, it would look like civilization appeared suddenly with agriculture 10,000 years ago. But in reality, we might be civilization attempt number 50. The reset theory helps explain something that's always bothered me about the traditional timeline. Why did humans and human-like beings exist for hundreds of thousands of years, then suddenly develop agriculture, cities, and writing, all within a relatively short period? The standard explanation is that it took that long for our brains to develop the necessary capabilities. But what if our brains were capable much earlier, and the recent explosion of civilization represents just the latest in a long series of developmental cycles? What if we're not seeing the dawn of human achievement, but the latest renaissance after the last great collapse? This possibility becomes even more intriguing when you consider the role of climate and extinction events. Earth's climate has been incredibly unstable over the past few 100,000 years. We've experienced multiple ice ages, dramatic sea level changes, volcanic winters from massive eruptions, and who knows what other environmental catastrophes. Each major climate shift would have been like hitting a reset button on any complex society. Groups that had developed sophisticated knowledge about agriculture, architecture, or technology would suddenly find themselves in completely different environments where none of their expertise applied. The survivors would be the ones who could adapt quickly to new conditions, not necessarily the ones who had preserved the most advanced knowledge. Over hundreds of thousands of years, these climate cycles could have wiped out dozens of potential civilizations before they had a chance to leave lasting traces. Each group might have reached impressive levels of development, only to be scattered by environmental changes that made their achievements irrelevant. But let's get even more specific about what we might be missing. When archaeologists study the deep past, they're working with an incredibly biased sample. Almost everything we know about ancient human comes from stone tools, because stone is one of the few materials that survives over vast time periods. But stone tools might represent only a tiny fraction of the technology that ancient peoples actually used. Think about your own daily life. How many of the tools and technologies you rely on are made of materials that would survive 400,000 years? Your smartphone, your clothes, your furniture, your transportation, your food storage systems, almost everything would be gone. Ancient peoples might have been incredibly sophisticated at working with wood, plant fibers, animal products, and other organic. Don't preserve materials that simply. They might have developed complex technologies for food processing, textile production, construction, and manufacturing that were far more advanced than the stone tools suggest. There's actually some evidence for this already. Wooden spears dating back 300,000 years have been found in Germany, but only because they happen to be preserved in very specific conditions. If a few wooden spears survived by pure chance, how many other wooden tools, structures, and technologies were lost forever? This preservation bias means we're trying to understand ancient peoples based on their most durable artifacts, not their most important or sophisticated ones. It's like trying to understand our modern civilization based only on the concrete foundations of buildings, while ignoring everything else we've created. The implications of this are staggering. What if the Stone Age wasn't really a Stone Age at all, but a Wood Age, a Fiber Age, a Biological Age, and we're only seeing the stone parts because that's all that survived? What if the apparent simplicity of ancient technology is just an illusion created by the selective destruction of everything except the most basic, durable items? This brings us to one of the most fascinating aspects of this entire question: the role of imagination in filling the gaps where evidence can't reach. And trust me, those gaps are absolutely enormous. When we start talking about imagination and evidence, we enter territory that makes a lot of scientists uncomfortable. And I get it. Science is supposed to be about facts, measurements, and verifiable data. But here's the thing that most people don't realize. When you're dealing with time spans this vast, imagination isn't the enemy of science. It's actually one of the most important tools we have. Think about it this way. Every major scientific breakthrough started with someone imagining possibilities that went beyond the accepted facts of their time. Darwin imagined that species could change over time when everyone believed they were fixed. Einstein imagined that time and space could bend when everyone thought they were absolute. Wegener imagined that continents could drift across the earth when everyone thought they were permanently locked in place. In each case, the imagination came first, then the evidence followed. The key is holding imagination accountable to reality while still allowing it to explore possibilities that pure evidence can't reach. So, what happens when we apply disciplined imagination to the question of ancient civilizations? What emerges is not wild fantasy, but a systematic exploration of what's actually possible given what we know about human intelligence, geological processes, and the nature of evidence itself. Let me walk you through a thought experiment that'll change how you think about this entire question. Imagine you're an alien archaeologist visiting Earth 1 million years from now. Humans have been extinct for hundreds of thousands of years. You're trying to figure out if intelligent life ever existed on this planet. You start digging around what used to be major population centers. Most of our cities are completely gone, obviously. The organic materials rotted away ages ago. The metals oxidized back into rust. The plastics broke down into microparticles that are indistinguishable from natural polymers. But you might find some clues. Unusual concentrations of certain elements in the soil. Geometric patterns in rock formations that seem too regular to be natural. Maybe some fragments of concrete or ceramic in very specific locations. Now here's the crucial question. Based on these scattered, ambiguous traces, would you be able to reconstruct the complexity of human civilization? Would you understand that we had global communication networks, space travel, genetic engineering, quantum computers? Or would you conclude that some moderately intelligent species once existed that was capable of basic tool use and construction? The honest answer is that most of the sophistication of our civilization would be completely invisible to you. You might recognize that intelligence was present, but you'd have no way of grasping how advanced it actually became. This scenario helps us understand why the absence of obvious evidence for ancient civilizations doesn't necessarily mean they never existed. If our own incredibly complex society would be nearly invisible after 1,000,000 years, what are the odds that we'd recognize the traces of a society that existed 400,000 years ago? But let's push this thought experiment even further. What if ancient civilizations developed along completely different technological pathways than ours? What if they became advanced in ways that we wouldn't even recognize as technology? Our civilization is built around manipulating inorganic materials. We dig metals out of the ground, refine them in massive industrial processes, and assemble them into complex machines. We harness energy by burning fossil fuels or splitting atoms. We store information in electronic devices made from silicon and rare earth elements. But what if another approach to civilization focused on manipulating organic systems instead? What if ancient peoples became incredibly sophisticated at breeding plants and animals for specific purposes? What if they developed biological technologies that could perform the same functions as our machines, but using living systems instead of manufactured ones? Imagine a society that could breed trees to grow into specific architectural shapes, creating living buildings that were stronger and more durable than anything we could construct. Picture agricultural systems so sophisticated that they could produce abundant food while actually improving soil quality and biodiversity over time. Envision communication networks based on biological signals that could transmit information across vast distances without any artificial infrastructure. These technologies would be completely invisible to archaeologists because they would look exactly like natural ecosystems. A forest of specially bred trees would appear to be just a forest. A sophisticated biological communication system would be indistinguishable from normal animal behavior. Agricultural techniques that worked with natural processes wouldn't leave behind the industrial scars that mark our farming methods. From our perspective, such a civilization would appear lived in perfect simple to have tools and basic harmony with nature, using only techniques. But in reality, they might have achieved levels of sophistication that surpass our own, just through biological manipulation rather than mechanical engineering. This isn't pure fantasy. We're already seeing the early stages of biological technology in our own time. Genetic engineering, synthetic biology, biocomputing. We're learning to program living systems to produce materials, process information, and perform complex functions. It's not hard to imagine these approaches becoming far more sophisticated over time. So, what would an archaeologist 400,000 years from now make of our current biological technologies? They probably wouldn't recognize them as technology at all. Genetically modified organisms would just look like organisms. Biological computers would appear to be natural biological processes. This perspective completely transforms how we think about technological development. Instead of imagining ancient civilizations as either primitive or as having technology similar to ours, we can envision societies that became advanced along entirely different trajectories. Maybe they focused on developing human consciousness and memory to extraordinary degrees instead of building external information storage systems. Perhaps they became masters of psychological and social technologies, creating forms of cooperation and organization that made them incredibly effective as a species without requiring permanent infrastructure. What if they developed mathematical and scientific understanding that was transmitted entirely through oral traditions and practical applications, leaving behind no written records, but achieving insights that matched or exceeded our own? The more I explore these possibilities, the more I realize that our definition of advancement might be incredibly narrow. We assume that progress looks like cities, writing, and machines because that's the path our civilization happened to take. But intelligence could have flowered in dozens of different directions, many of which would leave no traces that we'd recognize as evidence of sophistication. This brings us to one of the most profound implications of this entire line of thinking. If advanced civilizations could have existed and vanished without leaving clear evidence, then the story of intelligence on Earth might be far richer and more complex than we ever imagined. Instead of seeing ourselves as the first and only intelligent species to reach high levels of development, we might be just the latest chapter in a long book of experimentation with consciousness, technology, and social organization. Other chapters might have explored completely different approaches to the challenges of existence, developing solutions that we haven't even begun to consider. But here's where this gets really interesting from a practical standpoint. If we accept the possibility that other forms of advanced civilization might have existed and vanished, what does that tell us about our own situation? First, it suggests that achieving high levels of development doesn't guarantee permanence. Intelligence and sophistication don't automatically protect a species from collapse. Whatever advantages previous civilizations might have had, they weren't enough to ensure their survival across the vast spans of geological time. This should be deeply humbling for us. We often act as if our technological capabilities make us masters of our environment, as if we've somehow transcended the natural forces that shaped all previous life on Earth. But if other intelligent species rose and fell before us, it suggests that we're not as special or as secure as we like to believe. Second, it implies that the development of intelligence might be more common than we assume. Instead of being a unique accident that occurred only once in Earth's history, intelligence might be an emergent property that appears regularly when conditions are right, only to disappear when those conditions change. This has fascinating implications for how we think about life elsewhere in the universe. If intelligence can rise and fall repeatedly on a single planet, then the cosmos might be filled with civilizations at various stages of development and decline, most of them invisible to each other, across the vast distances of space and time. Third, it suggests that there might be natural cycles of development and collapse that operate on time scales far longer than human history. Just as ecological systems go through cycles of growth and decay, perhaps intelligence itself follows patterns of emergence, sophistication, and extinction that play out over hundreds of thousands of years. Understanding these cycles could be crucial for our own survival. If we could identify the factors that led to the collapse of previous civilizations, we might be able to avoid making the same mistakes. If we could understand the conditions that allow intelligence to flourish, we might be able to create more stable foundations for our own continued development. But there's another angle to consider here that's even more mind-bending. What if the traces of ancient civilizations aren't completely gone? What if they're hiding in plain sight, but we don't know how to recognize them? This is where we need to talk about the possibility that some of the things we consider natural features of our planet might actually be artificial. Think about this for a second. When you look at a mountain range, you see the result of millions of years of geological forces, tectonic plates colliding, rock layers folding and lifting, erosion carving valleys. It all looks completely natural, right? But what if some of those formations aren't entirely natural? What if scattered throughout our planet's landscape are structures so old that we've mistaken them for geological features? This isn't as crazy as it sounds. We already know that nature can mimic human construction in remarkable ways. Columnar basalt formations look like massive stone columns arranged in perfect geometric patterns. The Giant's Causeway in Ireland looks like it was built by ancient engineers, but it's entirely natural. So, if nature can accidentally create things that look artificial, couldn't artificial structures eventually look natural after enough time has passed? Imagine a massive stone pyramid built 400,000 years ago. Over geological timescales, weather patterns would erode its sharp edges. Plants would take root in cracks and crevices. Soil would accumulate on its surfaces. Freeze-thaw cycles would fracture the stone. Eventually, it might look like nothing more than an oddly shaped hill covered in vegetation. Now multiply this process across an entire civilization. Temple complexes become unusual rock formations. Engineered harbors look like natural bays. Carefully planned city layouts appear to be random patterns of hills and valleys. The boundary between artificial and natural becomes completely blurred. This possibility forces us to look at our planet with completely different eyes. That weirdly regular rock formation you drove past last weekend, maybe it's just an unusual geological accident. Or maybe it's the heavily eroded remains of something built by intelligent beings when your ancestors were still figuring out how to make fire. The underwater angle makes this even more intriguing. We've explored less than 5% of our ocean floors. The vast majority of the seafloor remains completely unmapped and unstudied. If ancient civilizations built near coastlines, as most civilizations do, then their remains are now sitting under miles of water, covered by thousands of years of sediment. Every so often, marine archaeologists or deep-sea explorers stumble across underwater formations that spark intense debate. The Yonaguni Monument off the coast of Japan looks remarkably like a stepped pyramid, complete with what appear to be stairs, platforms, and carved channels. Mainstream geology insists it's a natural rock formation shaped by erosion, but the geometric precision is startling enough to make you wonder. Similar formations have been found off the coasts of Cuba, India, and other locations around the world. In each case, the scientific consensus leans toward natural explanations. And honestly, that's probably correct most of the time. The ocean floor is full of weird geological features that can look artificial to our pattern-seeking brains. But here's what keeps me up at night. Even if 99% of these anomalous formations are completely natural, what about that 1%? What if scattered across our ocean floors are the genuine remains of construction so ancient that we can barely distinguish them from natural rock? The preservation conditions underwater are actually quite good in some ways. Cold temperatures, lack of oxygen, protection from surface weather. Some of the oldest preserved wooden artifacts we've ever found were pulled from the bottom of lakes and seas. If ancient structures were submerged quickly enough, portions of them might survive in recognizable form, but finding them would require systematically exploring millions of square miles of ocean floor, most of it buried under layers of sediment. We'd need to be looking specifically for artificial structures, and we'd need to know what to look for. Given that we're still discovering new species of fish and mapping basic underwater geography, the odds of stumbling across ancient ruins by accident are pretty slim. This brings up another fascinating angle. What if the evidence isn't just hidden underwater or disguised as natural formations? What if some of it is hidden in the one place we'd never think to look? Inside our own DNA. Stay with me here, because this gets wild. Every living thing on Earth carries a complete record of its evolutionary history encoded in its genetic material. Your DNA contains traces of every ancestor you've ever had, going back billions of years to the first single-celled organisms. But DNA isn't just a historical record, it's also incredibly information-dense. A single gram of DNA can theoretically store about 215 petabytes of data. That's more storage capacity than every computer on Earth combined. Now, we know that ancient peoples were capable of selective breeding. They domesticated plants and animals, gradually modifying their genetics over many generations to enhance useful traits. But what if some ancient civilization became so sophisticated at genetic manipulation that they started using living organisms as information storage systems? Picture a society that encoded their knowledge directly into the DNA of certain species, mathematical principles stored in the genome of a particular tree, historical records embedded in the genetic structure of a domesticated animal, technical specifications for advanced technologies hidden in the DNA of food crops. These information systems would be completely invisible to us unless we knew exactly what to look for and how to decode it. The organisms would appear completely normal. They'd reproduce naturally, passing the encoded information down through generations. But buried within their genetic code would be libraries of knowledge from a civilization that vanished hundreds of thousands of years ago. This isn't entirely science fiction. We already use DNA for data storage in laboratory settings. Scientists have successfully encoded everything from books to movies in genetic material. And we know that some segments of DNA can remain stable for extremely long periods under the right conditions. What if the reason certain species seem unusually well adapted to living alongside humans isn't just because we domesticated them? What if they carry genetic modifications made by a previous civilization, modifications that make them useful companions for any intelligent species that develops agriculture and permanent settlements? Dogs, for instance. Their relationship with humans is remarkably sophisticated and seems to have developed surprisingly quickly in evolutionary terms. What if the genetic changes that made dogs such perfect human companions weren't entirely the result of our selective breeding? What if they were building on modifications made by an earlier civilization that also recognized the value of having intelligent, loyal animal partners? I know this sounds like something out of a science fiction novel, but when you're dealing with time spans this vast and the complete absence of conventional evidence, you have to consider information storage and transmission methods that go way beyond stone tablets and written records. The more I think about these possibilities, the more I realize we might be surrounded by evidence we don't know how to interpret. Ancient knowledge encoded in genetics. Artificial structures disguised as natural formations. Technologies so different from ours that we wouldn't recognize them as technologies at all. But let's step back from these speculative ideas and focus on something we can actually verify. The weird stuff that archaeologists have already found. Throughout history, excavations have turned up objects that don't quite fit the accepted timeline. These are called out-of-place artifacts. And while most of them have reasonable explanations, a few remain genuinely puzzling. Take the Antikythera mechanism, discovered in a Roman-era shipwreck off the coast of Greece. When it was first found, nobody could figure out what it was. It looked like a corroded lump of bronze with some gears sticking out. But as researchers studied it more carefully, they realized it was an incredibly sophisticated mechanical computer designed to predict astronomical events. The level of precision and complexity was unlike anything we thought the ancient Greeks could build. It completely changed our understanding of ancient mechanical engineering capabilities. And here's the thing that gives me chills. If we hadn't found this one device by pure chance, we never would have known that such technology existed in the ancient world. How many other sophisticated devices were built throughout history, but didn't happen to survive in the archaeological record? How many times have we underestimated the capabilities of ancient peoples simply because most of their achievements disappeared over time? The Antikythera mechanism is only about 2,000 years old, which is practically yesterday compared to the time spans we're discussing. But it proves that human ingenuity can produce surprising bursts of sophistication that are far ahead of what we expect for any given period. If that can happen within recorded history, it's not unreasonable to imagine similar bursts of innovation happening in the much deeper past. Groups of people experimenting with ideas, developing techniques, creating technologies that were advanced for their time, but ultimately didn't survive long enough for us to discover them. There are other anomalous artifacts scattered throughout the archaeological record. Metallic objects found in geological layers that seem too old for the accepted timeline of metallurgy. Stone carvings that appear to show sophisticated understanding of astronomy or mathematics earlier than we thought such knowledge existed. Most of these finds have conventional explanations, dating errors, misidentified natural formations, contamination from later time periods. The scientific process is pretty good at filtering out false claims and mistaken interpretations. But every now and then, something turns up that doesn't fit neatly into any category. Not dramatic enough to rewrite history, but weird enough to make researchers scratch their heads and wonder if there might be gaps in our understanding. These outliers matter because they remind us that our reconstruction of the past is based on incomplete information. We're working with fragments and trying to build a complete picture. Most of the time our interpretations are probably accurate, but occasionally we might be missing something important. The existence of these puzzling finds doesn't prove that advanced civilizations existed 400,000 years ago, but it does suggest that the story of human development might be more complex and surprising than the neat timeline in textbooks implies. And that brings us to one of the most important lessons of this entire exploration. The value isn't necessarily in proving or disproving the existence of ancient civilizations. It's in what the question teaches us about the nature of knowledge, evidence, and the limits of what we can know about our own past. When we seriously consider the possibility that sophisticated societies might have risen and fallen long before recorded history, we're forced to confront some uncomfortable realities about the fragility of everything we've built. Our cities, our technologies, our knowledge systems, our entire civilization. None of it is guaranteed to last. This perspective should make us more humble about our place in the grand timeline of Earth's history. We tend to think of ourselves as the pinnacle of development, the first and only species to achieve this level of sophistication. But what if we're just the latest experiment in intelligence? What if consciousness and technology have been emerging and disappearing for far longer than we realize? That possibility changes everything about how we see ourselves and our responsibilities. If other civilizations rose and fell before us, then we're not unique pioneers blazing a trail into the future. We're participants in a much larger story, one that stretches back far further than we ever imagined. And if previous experiments in intelligence ultimately failed to survive, that should serve as a warning about our own vulnerability. Whatever advantages we think we have, whatever protections we believe our technology provides, history suggests that no level of advancement guarantees permanence. But there's also something oddly comforting about this possibility. If intelligence has emerged multiple times throughout Earth's history, it suggests that consciousness and creativity aren't fragile accidents that happened only once. They might be fundamental properties of the universe that keep reappearing whenever conditions are right. Even if our current civilization eventually collapses, intelligence itself might be more resilient than we think. Other forms of consciousness might emerge from the ruins of our experiment, just as we might have emerged from the ruins of previous attempts. This long view of intelligence and civilization puts our current challenges in a completely different context. The more I explore these long-term perspectives on civilization, the more I realize we might be asking the wrong questions entirely. Instead of wondering whether advanced societies existed 400,000 years ago, maybe we should be asking what happens to intelligence when it encounters the ultimate test of time. Because here's something that'll blow your mind. Every single challenge we face as a modern civilization has probably been faced before. Climate change, resource depletion, overpopulation, social inequality, technological disruption. These aren't new problems. They're the eternal challenges that any sufficiently complex society eventually confronts. Think about it this way. If you develop agriculture, you eventually face soil depletion and the need for more land. If you build cities, you eventually deal with waste management and disease transmission. If you develop industry, you eventually confront pollution and resource scarcity. If you create complex social hierarchies, you eventually face inequality and social unrest. These challenges aren't bugs in the system of civilization. They're features. They're the inevitable consequences of intelligence organizing itself into complex societies. And here's the kicker. They're also the tests that determine whether a civilization survives or collapses. So, if other advanced societies existed in the deep past, they would have faced these same fundamental challenges. Some might have found solutions we haven't thought of. Others might have failed in ways that could teach us valuable lessons about what doesn't work. But here's where it gets really interesting. What the reason we can't find clear evidence of ancient civilizations isn't just because time erased the traces. What if it's because the successful ones learned something we haven't figured out yet? Let me paint you a picture that might sound crazy at first, but bear with me. What if truly advanced civilizations eventually realize that leaving permanent marks on the environment is actually a sign of primitive thinking? What if the highest form of technological development involves learning to live in complete harmony with natural systems? Our current civilization is incredibly wasteful and destructive. We dig massive holes in the ground to extract resources. We pump pollution into the air and water. We cover vast areas with concrete and asphalt. We're basically strip mining the planet and leaving scars that will be visible for millions of years. But what if that's just because we're still in the early stages of technological development? What if mature civilizations eventually figure out how to meet all their needs without leaving any permanent environmental impact. Picture a society that learned to manipulate biological systems so efficiently that all their technology was essentially alive. Buildings that grew instead of being constructed, transportation systems based on trained animals or biological mechanisms, manufacturing processes that worked like natural ecosystems, with every waste product from one process becoming the input for another. Such a civilization could potentially support billions of people at high levels of comfort and sophistication while leaving virtually no archaeological trace. After they were gone, their cities would decompose back into forests. Their transportation networks would return to natural migration routes. Their manufacturing sites would become thriving ecosystems. To us, it would look like they never existed at all. But in reality, they might have achieved something we're still struggling toward. True sustainability at a civilizational scale. This possibility completely flips our assumptions about what advancement looks like. We tend to equate progress with bigger, more permanent, more visible impacts on the environment. But what if real progress means learning to achieve more while impacting less? What if the civilizations that left the biggest archaeological footprints were actually the least successful ones? The ones that never figured out how to live sustainably and eventually collapsed under the weight of their own environmental destruction. From this perspective, our current civilization might be following the same doomed path as previous failed experiments. We're certainly leaving plenty of archaeological evidence for future researchers to find. But that might not be something to be proud of. Now, I want to be clear here. I'm not saying this definitely happened. I'm not claiming we have proof that sustainable super civilizations existed in the past. But I am saying that the absence of evidence doesn't rule out this possibility, and exploring it might teach us something crucial about our own trajectory. Because here's the thing that really keeps me up at night. If previous civilizations did exist and collapse, we might be repeating their mistakes without even realizing it. We might be caught in a cycle that's played out multiple times throughout Earth's history, with each iteration making the same fundamental errors. Or maybe we're not. Maybe we're the first to reach this level of technological capability. Maybe we're writing the first chapter of a completely new story. But even if that's true, thinking about these possibilities changes how we approach the challenges we're facing. If intelligence has emerged and disappeared multiple times, then our current moment becomes incredibly precious. We might be carrying the torch of consciousness through a critical transition period. The decisions we make in the next few decades could determine whether intelligence survives and flourishes on Earth, or whether it goes through another reset cycle. This perspective makes every environmental protection effort, every step toward sustainability, every advancement in renewable energy feel like part of a much larger story. We're not just trying to maintain our current standard of living. We're trying to prove that intelligence can learn to coexist with the natural world instead of destroying it. And if we succeed, we might be the first civilization in Earth's history to break the cycle of rise and collapse. We might be the ones who figure out how to build something that lasts not just for thousands of years, but for millions or billions of years. But there's another angle to this that's even more mind-bending. What if the cycle of rise and collapse isn't a bug, it's a feature? What if intelligence itself is part of Earth's long-term evolutionary strategy? Think about it this way. Earth has been running experiments in complexity for billions of years. Simple molecules became complex molecules, became self-replicating systems, became cells, became multicellular organisms, became ecosystems, became us. Each step in this process involved periods of rapid innovation followed by stabilization or sometimes collapse and restart. Mass extinctions cleared the stage for new forms of life to emerge. Ice ages and climate changes forced evolutionary adaptations that led to greater complexity. What if the emergence of intelligence represents just the latest phase in this experimental process? What if Earth periodically develops intelligent species that explore different approaches to technology and social organization, then resets the system to try new variations? From this perspective, individual civilizations aren't meant to last forever. They're meant to explore specific possibilities, push certain boundaries, then make way for the next experiment. The value isn't in permanence, but in diversity of exploration. If this is true, then our current civilization represents just one attempt among many to figure out what intelligence can accomplish. Other attempts might have explored completely different paths. Biological technology instead of mechanical, collective consciousness instead of individualism, symbiotic relationships with other species instead of domination. Each experiment would have contributed something to the overall development of intelligence on Earth, even if the individual civilizations didn't survive. Knowledge, techniques, and evolutionary pressures that influenced the next attempt. This view makes the question of ancient civilizations even more fascinating. We wouldn't just be looking for evidence of societies like ours. We'd be looking for traces of completely alien approaches to the problems of existence. Forms of intelligence and technology that might be so different from our experience that we wouldn't even recognize them as artificial. Maybe some ancient civilization developed forms of consciousness that were distributed across multiple species instead of concentrated in individuals. Maybe they figured out how to store information and processing power in geological formations or atmospheric patterns. Maybe they learned to manipulate time and space in ways that our physics hasn't discovered yet. These possibilities sound like science fiction, but remember, to someone from 400,000 years ago, our current technology would sound like magic. Instantaneous global communication, machines that can fly through the air, the ability to see inside living bodies without cutting them open, devices that can store thousands of books in something smaller than your fingernail. If intelligence has been experimenting with different approaches for hundreds of thousands of years, then the range of possibilities we haven't considered yet might be absolutely staggering. But let's bring this back down to Earth for a moment. Whether or not ancient civilizations actually existed, thinking about these possibilities teaches us something crucial about our current situation. It shows us just how many different paths forward are theoretically available to us. We tend to assume that technological development follows a predetermined course. Stone tools lead to metal tools, lead to machines, lead to electronics, lead to whatever comes next. But that's just one possible pathway among many. What if we deliberately chose to explore biological technology instead of continuing down the mechanical path? What if we focused on developing human consciousness and social cooperation instead of building bigger and faster machines? What if we prioritized understanding natural systems instead of trying to control them? Each of these approaches might lead to forms of civilization that would be unrecognizable to us today, but potentially far more sustainable and fulfilling than what we're currently building. The question of ancient civilizations forces us to confront the limits of our imagination about what's possible. It challenges us to think beyond our current assumptions about progress, technology, and the future of intelligence. And that brings me to the most important point of this entire exploration. Regardless of whether advanced societies existed 400,000 years ago, the act of seriously considering this possibility changes how we see ourselves and our place in the cosmic timeline. It makes us more humble about our achievements while simultaneously more aware of our potential. It shows us that intelligence is both more fragile and more resilient than we typically assume. It reminds us that the story we're part of is much larger and more mysterious than we usually recognize. Most importantly, it emphasizes that we're not passive observers of history. We're active participants in an ongoing experiment that's been running for hundreds of thousands, maybe millions of years. The choices we make, the paths we pursue, the problems we solve or fail to solve, all of this contributes to the larger story of intelligence on Earth. Whether we're the first chapter in this story or just the latest chapter, we have a responsibility to make our contribution count, to learn from whatever came before, to avoid the mistakes that might have led to previous collapses, and to explore new possibilities that might lead to genuine long-term success. The question isn't really whether ancient civilizations existed. The question is what we're going to do with the incredible opportunity we've been given to participate in the ongoing experiment of intelligence. And that question, unlike the mystery of the deep past, is entirely up to us to answer. But before we can answer it effectively, we need to understand something crucial about the nature of evidence, knowledge, and the strange relationship between what we can prove and what might actually be true. Here's the thing that blows my mind about evidence and truth. We live in a world where we can detect gravitational waves from black holes colliding billions of years ago, but we can't definitively say what happened on our own planet 400,000 years ago. We can measure the chemical composition of distant stars, but we're essentially blind to entire chapters of our own story. This isn't just about ancient civilizations. This is about the fundamental nature of knowledge itself and how much of reality remains hidden from us. Not because it's impossible to know, but because the evidence simply doesn't survive long enough for us to examine it. Let me give you an example that'll make this crystal clear. Right now, somewhere on Earth, there are probably dozens of species going extinct that we've never even discovered. Plants, insects, maybe even small mammals that evolved, lived, and disappeared without leaving any trace we'll ever find. Future biologists will have no idea these creatures ever existed. If we can't even document all the life forms that exist right now, in our current moment, with all our advanced technology, how can we possibly claim certainty about what existed hundreds of thousands of years ago? The hubris is staggering when you really think about it. But here's where it gets even more interesting. The absence of evidence creates a kind of epistemological vacuum, a space where speculation and imagination become not just useful, but necessary tools for understanding. When facts can't reach, logic has to bridge the gap. And that's where things get weird. Because when you start applying rigorous logical analysis to the question of ancient civilizations, you realize that their existence isn't just possible. In some ways, it's almost statistically inevitable. Think about this mathematically. We know that human-like intelligence existed for hundreds of thousands of years. We know that climate and environmental conditions varied dramatically during that time. We know that some periods were actually more favorable for development than others. We know that human beings are incredibly adaptable and innovative. Given all those variables, what are the odds that in all that time, across all those different environmental conditions, with all those different groups of intelligent beings, nobody ever pushed beyond basic hunter-gatherer survival? What are the chances that development remained static for hundreds of millennia, then suddenly exploded into civilization just 10,000 years ago? When you frame it that way, the traditional timeline starts to look less like historical fact and more like a statistical anomaly. It's like flipping a coin 1,000 times and getting heads every single time except for the last 10 flips. Possible? Sure. Likely? Not really. This is what I call the development paradox. The longer intelligence exists without apparent progress, the more likely it becomes that progress actually did occur, but left no traces we can detect. It's counterintuitive, but mathematically sound. And here's another angle that'll mess with your head. What if evidence of ancient civilizations does exist, but we're looking for it in completely the wrong way? What if we're so focused on finding things that look like our civilization that we're missing evidence of entirely different approaches to intelligence and technology? I mentioned biological technology earlier, but let me push that idea further. What if an ancient civilization developed what we might call geological technology? What if they learned to manipulate rock formations, mineral deposits, and even tectonic processes to serve their purposes? Picture a society that could influence the formation of underground water systems, creating aquifers and springs exactly where they needed them. Imagine people who understood geological processes so well that they could encourage the formation of useful mineral deposits or even influence the shape of landscapes over time. This kind of technology would be almost invisible to us because we'd interpret its results as natural formations. An artificially created mountain range would look exactly like a natural one after a few thousand years of weathering. A deliberately shaped river system would appear to be the result of normal erosion patterns. But the capabilities required for this kind of geological engineering would represent a level of understanding about Earth systems that far exceeds our current knowledge. It would require incredibly sophisticated science, mathematics, and long-term planning. Yet, it would leave virtually no archaeological signature that we'd recognize as artificial or consider atmospheric technology. What if an ancient civilization learned to manipulate weather patterns, atmospheric chemistry, or even electromagnetic fields in ways that served their purposes? They could potentially influence rainfall, temperature, or growing seasons across vast regions without leaving any permanent structures behind. These technologies would be based on understanding and working with natural systems rather than building artificial replacements for them. They'd be sustainable by definition because they'd be using the planet's own processes to achieve their goals. From our perspective, such technologies would be essentially magical. But from the perspective of a civilization that developed along those lines, our approach of digging up resources and building mechanical devices might seem incredibly primitive and wasteful. This brings up a fascinating possibility. What if the reason we haven't found clear evidence of ancient civilizations isn't because they didn't exist, but because they were more advanced than us? What if truly sophisticated societies eventually learn to achieve their goals without leaving the kind of environmental damage that we associate with development? It's like the difference between a surgeon who leaves huge scars and one who performs microsurgery that heals without a trace. Both accomplish their goals, but only one leaves obvious evidence of their intervention. Now, I know what you're thinking. This is starting to sound like I'm arguing that ancient civilizations had magical powers or supernatural abilities, but I'm not. I'm suggesting that there might be approaches to science and technology that we haven't discovered yet. Approaches that could achieve remarkable results without requiring the massive industrial infrastructure that characterizes our current civilization. Consider how much our understanding of physics has changed just in the past century. Quantum mechanics, relativity, nuclear physics, particle physics, all of these were completely unknown to scientists in 1900. The technological capabilities we have today would seem like magic to someone from that era. Now extrapolate that rate of discovery forward. If our physics continues advancing at the same pace, what will we understand about the universe in another century? What technologies might become possible that we can't even imagine today? If human-like intelligence has existed for hundreds of thousands of years, and if development did occur during some of that time, then the scientific understanding achieved by ancient civilizations might be centuries or millennia ahead of where we are now. They might have discovered principles of physics, chemistry, and biology that we're still working toward. But here's the crucial point. Advanced understanding doesn't necessarily require advanced infrastructure. You could potentially develop incredibly sophisticated theories and techniques using relatively simple tools, especially if you had thousands of years to refine and perfect them. Ancient Greek mathematicians made discoveries that we still use today, and they did it with nothing more than geometric drawings and sand. Indigenous peoples around the world developed complex systems of astronomy, navigation, and ecological management using tools we'd consider primitive. If you give highly intelligent people enough time and the right environmental conditions, there's no telling what they might figure out, even without electronic computers or industrial manufacturing capabilities. This perspective transforms how we think about the relationship between technology and archaeology. We tend to assume that advanced capabilities require massive permanent structures that would leave clear traces. But what if the most advanced technologies are actually the ones that work so elegantly with natural systems that they become invisible over time? The more I explore these possibilities, the more I realize that our current approach to archaeology might be fundamentally limited. We're looking for evidence of civilizations like ours, using methods designed to find traces of industrial development. But if ancient societies developed along completely different lines, using different principles and different approaches, then our search methods might be completely inadequate. It's like trying to find evidence of classical music by looking for electric guitars. You're using the wrong tools to search for the wrong thing, so naturally you don't find anything. But that doesn't mean music didn't exist. It just means you're not looking for it in the right way. This has profound implications for how we should be thinking about our own development. Instead of assuming that our current technological path is the only viable approach, maybe we should be exploring some of these alternative possibilities. So here we are, at the end of this mind-bending journey through deep time and deeper questions. Whether advanced civilizations existed 400,000 years ago or not, we've discovered something far more valuable than any ancient artifact could provide. We've learned that the story of intelligence on Earth is far stranger, far more fragile, and far more magnificent than we ever imagined. The silence of the archaeological record isn't proof of absence. It's proof of just how vast and mysterious our own history really is. And maybe that's exactly the perspective we need right now, as we write our own chapter in this cosmic experiment called consciousness.